So we were discussing about the derivatives of a curve and the turning point. So and derivatives tells us the slope of a curve. For example, here you can see a parabola. So for parabola, at every point, if we draw a tangent, so we are getting slope of curve at that particular point. So these slopes are telling us the derivative. And let me draw with some distinct color. Yeah. So every point there is a slope. So I just draw like 3 points here, but there are more. So you see over here, so this slope is negative, right? Slope of the tangent is negative. So it is coming down, down, down. So it is increasing, or we can say like it's decreasing in the negative side. So like it's more negative and then it's getting less negative, negative, and at some point it becomes zero and then it start increasing, right? It start getting positive, and on positive side slope is increasing, increasing, and increasing. So when the slope become zero, so that is the turning point, because slope is coming from negative and it's going towards positive. So that is a turning point. Remember, line of when we have a straight line, like let me draw it like this. Is there any turning point? No, there is no turning point, right? So it has a constant slope. When we have a constant slope, there is no turning point. So y is equal to mx plus c. And when we have a parabola, so we see like for parabola, so there is a turning point, whether it's going from uh, negative slope towards positive slope, means it's facing upward or it's facing downward. When it's facing downward, so it means we have some like positive slope become zero and then going negative slope. The important thing is slope from negative is going towards positive. If it's going from negative towards positive, so at one point it has to be zero. Similarly, when we have like this parabola facing upward, facing downward, so it's the maximum point. So slope is positive. At some point, it has to be negative. Before going to negative, at some point it has to be zero, and then it goes negative. Because from positive, it cannot go suddenly to negative, so it's changing gradually. So from positive slope coming to zero and then going towards negative. So where the slope is negative, that is a turning point. It could be a minimum point, it could be a maximum point. Remember in physics, when we throw some projectile up, suppose a ball, it goes up, 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 and at some point its movement becomes zero, and then it start coming down. Or for example, for pendulum, so if this is pendulum, so it's moving right and left, to and fro. So when it changes its direction, so its movement becomes zero. Or over here, when it changes its direction, its movement becomes zero. So whenever it has to change the direction, it becomes zero. Same thing happened with the slope. So when the slope changes its direction from positive to negative or from negative to positive, it has to go through its slope is equal to zero. So we know like slope is the derivative. So dy by dx is gradient, rate of change, slope of the function. So over here in parabola, so there is one turning point, but we know like if it's cube, so we may have more than one turning point, two turning points. If it is like power 4, we may have three turning points, 1, 2, 3. Or in general, if like there could be infinite turning points, for example, in sine, graph of sine. So after every period, it's changing its direction. So there are so many turning points. So there could be many, many, many turning points for different functions. For complex function, there could be much more turning points. Right now, we keep it simple. For example, for parabola. So there's one turning point in parabola in quadratic function. So where there is a turning point, it means slope become equal to zero, derivative become equal to zero. So it means dy by dx become equal to zero. When dy by dx is zero, so we have to find coordinate of the point where dy by dx, the gradient, the derivative is zero. We take an example. For example, Over here, the example is given y is equal to x square minus 4x plus 1. Y is equal to x square minus 4x plus 1. We know it's like orientation of the curve of the parabola is facing upward because the coefficient of x square is positive. When a is positive, so it's facing upward, a is negative, facing downward. So in this case, we are talking about a is positive, so it's facing upward. So we know it's going to be like turning point is going to be a minimum point. But let's see. First of all, where is the turning point? So we take dy by dx, which is in this case, apply the power rule. So it's 2x minus 4. So at turning point, derivative is 0. So dy by dx is equal to 0. That means 2x minus 4 is equal to 0. X is equal to 4 over 2. So that is 2. And what is the value of y at that point? So y is equal to, in our main equation, we put value of x that we found. So this is 2 square minus 4 into 2 plus 1. 2 square is 4 minus 8 minus 4 plus 1. So we get minus 3. So our turning point coordinates are 2 and minus 3. So let's draw this curve. How would it look like? I just draw it over here. So this curve will look like something where we have turning point at 2 and minus 3. Suppose this are our grid and we can draw it with some good color. So this is x is equal to 1, x is equal to 2. And over here, minus 1, minus 2, minus 3. So this is our turning point. So it will go somewhere like this and this. We can find its y-intercept, we can find its x-intercept. But the thing is, like, if we want to find the turning point where we have line of symmetry, so this is x is equal to 2 and y is equal to minus 3. And we can compute the graph of quadratic function as we used to do. So this is about the turning point. We take the derivative, put derivative equal to 0. So this will give us turning point. Remember, turning point could be a maximum point, it could be a minimum point. Now the question is, how do we decide whether a turning point is a max point or a min point? So we look at the slope. At that point, slope is increasing or decreasing. So what is slope? Slope is rate of change of the function. And if you look at the rate of change of slope, that means we are taking derivative of the derivative. So let's have a look at this thing. Let me erase this thing and we discuss about second derivative. Second derivative means we have derivative of the function and we take derivative of derivative. So rate of change of slope. What is the rate of change of slope? So we have to see this thing. So suppose we on the left side you see two graphs. So over here we see how is slope going. So I draw the slope over here. So over here the slope is negative, right? It's facing in the negative. It says facing going towards down. So it's like slope is negative. And if I come here, slope is still negative, but it's less negative. It's getting close to 0. And then it becomes 0 and then it is increasing. Slope is changing at every point, right? So over here it's more negative, getting less negative, becoming 0, positive, more positive, and even more steeper, more positive. If slope is changing, when there is a change, so that means we can calculate rate of change. Remember rate of change is derivative. Derivative is we call gradient, we call slope, we call rate of change, we call like tangent to the curve. So we find its slope or we call derivative. So rate of change means derivative. We take differentiation derivative. So, and we know like rate of change of what? Rate of change of slope. So derivative of slope. This means this is a second derivative of derivative of the slope. So how will it work? For example, we have got function, we take the same old function, previous function, we were choosing 2x square minus 4x plus 1. Suppose this is our function. So what is the derivative? That is, what is its slope? dy by dx is 4x minus 4. 4x minus 4 is a line, equation of a line, mx plus c, equation of a line. Whenever we have a straight line, y is equal to mx plus c, it means it has some slope. M is the slope. 4x minus 4. So if I draw 4x minus 4, so it's something like going through minus 4. So it's something like this. So we can see like over here, slope is, the function is, which is a derivative. So this derivative is negative. It becomes 0 at some point and then it becomes positive. And its rate of change is constant. So over here we see like it's negative, slope is negative, and it's getting close to 0. It becomes 0 and then it's going positive. So whenever slope is going from negative towards positive, so it means it's going through a valley. So it's touching a minimum point where slope is negative and then it's going positive. So we take the second derivative to see what is the rate of change of our first derivative. So second derivative is written like this, d square y by dx square. In other words, we are taking d by dx, that is derivative of first derivative, dy by dx. So we are taking d by dx derivative of 4x minus 4. 4x minus 4. We know this is straight line, its derivative is going to be a constant term, 4. 4x derivative of 4x is 4 and derivative of minus 4 is 0. So we've got d square y by dx square, which is equal to 4. And this is a positive number. If it is a positive number, it means slope is increasing, going from negative towards positive. So this kind of behavior happen when we have a valley, when we have a minimum point. So our turning point is a minimum point. So what was our turning point? Whatever it is, we can find from here 4x minus 4, put it equals to 0. So x is equal to 1. X is equal to 1 and y is equal to 2 minus 2 plus 1. So minus 2 plus 1 is going to be minus 1. Minus 1. X is equal to 1, y is equal to minus 1. So at that point, the graph is minimum. So if we have got a negative head coefficient, in that case, it's going to be a maximum. So in maximum, we see over here, slope is positive and it's getting less positive. It's becoming 0 and then it's becoming negative. It means when we have a maximum point, the turning point is maximum point. At that point, the second derivative, d square y by dx square, has to be negative. Because from positive, it's going towards negative. So it means rate of change of slope is negative. So we can solve some example for it. So finding the gradient on either side of the curve. So this is one another way, like instead of gradient, if we can take, suppose we take from our turning point, we see on the right and left of the point of our turning points. So how is the behavior of it? So first, let me do with the gradient and then I come back to this thing. So using the second derivative, for example, we have equation x square minus 4x plus 1. So we have already done actually this thing. Let me write it down over here. X square minus 4x plus 1 is first derivative is dy by dx, 2x minus 4. We put it equal to 0 to find its turning point. X is equal to 2. Whether it's minimum or maximum, we look at the rate of change of slope. Slope is increasing or decreasing, second derivative. So d by dx of 2x minus 4, which is equal to 2. 2 is positive. It means slope is going from negative to 0 and then to positive. So this is a minimum point, right? So another way to look at whether it's a minimum point or a maximum point, it's check wherever we have a turning point, we check the vicinity of turning point, the neighboring we take some neighboring points of the turning point. For example, over here we have turning point x is equal to 2 turning point. So we look at the behavior of slope at left of the turning point and right of the turning point. So suppose we take some point 2.1 and some on the left side we take suppose 1.9, and we see slope is increasing or decreasing. Actually, it's same thing like we are looking at second derivative. Slope is increasing or decreasing. So suppose x is equal to 1.9. Our turning point is at 2. So we see little before the turning point at x is equal to 1.9. So dy by dx, its slope is 2 1.9 minus 4. 2 into 1.9 is 3.8 minus 4 minus 0.2, which is negative. So slope is negative. And then at x is equal to 2.1, after turning point, do we get a positive slope? This is important to check. I tell you the reason. Dy by dx. So let's check this one. So at 2.1 minus 4. 2 into 2.1 is 4.2. 4.2 minus 4 is 0.2. So this is positive. So slope is changing from negative to 0 and then to positive. That's why it's turning point. So from negative, 0 and then positive. So it means this should be a minimum point. If we have got behavior of slope is like this, first is positive, then becomes 0 and then negative, then it's going to be max point. Why I say like we have to check on both sides. Actually, in some cases, it happens that derivative becomes 0, but it doesn't change the direction. Such kind of behavior is called point of inflection. I write it down over here, point of inflection. Point of inflection. So point of inflection, I draw some graph and show it to you. Point of inflection. In IGCSE, you are not asked about point of inflection. I'm just explaining to you. So sometimes it happens like some curve is going like this. It doesn't change its direction. It keep on increasing. But what happens over here is, over here's graph, slope is positive. It becomes 0 at some point. Actually, it's just passing through it. And then it's still positive slope. Just the tangent takes its change its direction. First it's above the curve, then it becomes below the curve. So there comes a point which is called point of inflection, where derivative dy by dx is 0. So that's why we have to check little before the turning point and after the turning point, that it should change its direction, like from here negative to positive. If it remain positive and then still positive, or it remains before turning point it says negative and after turning point still it's negative, then it's not a minimum or a maximum, it's simply point of inflection. But this is something that you will cover later in A levels, not for IGCSE. Okay, this is done. So we move to some example. We do secondary. So let's do this example. So example 20, this one, y is equal to 2x cubed minus 3x squared plus 1. So this is a cubic graph. So we will have multiple turning points. In fact, 2 turning points, right? So let's do this one. This could be interesting question. So we have 2 turning points and we have to figure it out whether those turning points are minimum or maximum. Which turning point is min and which turning point is max. So let's do it. So y is equal to 2x cubed minus 3x squared plus 1. So the first thing we always do is take the derivative. Y is equal to 2x cubed minus 3x squared plus 1. So dy by dx, this will give us turning points. Where derivative is 0, that is turning point. So this is 6x squared. We apply power rule of derivative minus 6x. Plus 1 is 0. Derivative of plus 1 is 0. So 6x squared minus 6x. This is derivative. For turning points, we put derivative equal to 0. So if derivative is 0, we can simply factorize it and solve this one. 6x squared minus 6x is 0. Take 6x gone. And inside we are left with x minus 1. So we can just remove 6. So either x is 0 or x minus 1 is 0. X minus 1 is 0 means x is equal to 1. So we have got turning point at x is equal to 0, x is equal to 1. So turning points, we can find y coordinates, but actually we don't need over here. If we have to sketch the graph, then we need y coordinates. So right now, keeping things simple, straight, x is equal to 0, x is equal to 1. And these two x coordinates, we have got turning points. So the question is, which turning point is max and which turning point is min? We can simply take the second derivative. So to find whether a turning point is min or max, what we have to do is simply take second derivative. So let's take derivative of the derivative. D square y over dx square is equal to dy by d by dx of dy by dx d by dx of 6x square minus 6x. 6x square minus 6x. We already calculated the derivatives, so we take derivative of this. So this become 6x square, 12x minus 6x, so its derivative is 6. This is second derivative. So second derivative will tell us whether our turning points are minimum points or maximum points. So how to find it out? So at x is equal to 0, d square y by dx square is positive or negative. So d square y over dx square is equal to 12 into 0 minus 6, which is negative. Is it min or max? It has to be max because slope is going from positive towards negative. Rate of change of slope is negative, means slope is decreasing. Slope is going from positive towards negative side. So that's why this is rate of change of slope. How slope is changing, this behavior is negative. So this happen when it's a maximum point, max. And the other turning point at x is equal to 1. Then our second derivative, d square y by dx square is 12 into 1 minus 6. 12 minus 6 is equal to 6, which is positive. So it means our slope is, rate of change of slope is positive. Slope is changing in a positive direction, it is increasing. Slope is coming negative, becomes 0 at turning point, and then it becomes positive. So this behavior is at a min point. So x is equal to 1 is our min point. So we have figured it out which point is the max point, which one is min point. Summarize. So we have to, when we have to solve these kind of questions, what we have to do? I just put everything over here. Summary. So let me clean this space so we can write down summary over here. So summary is, the first thing is take the derivative of the function. It's better if it's factorized form. So open it, multiply it, expand it. So find dy by dx, right? Second point is we have to find turning points. Find turning points. How to find turning points? Put dy by dx is equal to 0. That we calculated in the first point, put it equal to 0 and solve for x. We have got x coordinate of turning points. You can find y by putting value of x into our expression y is equal to something, something, something in terms of x, right? We have found turning points. Now we have to figure it out whether it's minimum or maximum point. So find whether it's min or max. So how we do it? We calculate second derivative d square y by dx square, what we calculated in the second step, right? So we have got something. So put the values of x from the turning points. Put turning point coordinates. Put turning point values of x. Values of x. So suppose we have x1, x2, x3, some numbers. So if d square y by dx square is positive, if then means this x is a min point. If d square y by dx square is negative, that means we have got a max point. So min point means slope is changing from positive to negative. So it's a valley, right? So max point means slope is positive, coming zero and going negative. So it's a hump. So this is going, slope is going from, so min point, sorry, this is from negative to positive, right? So first it's negative, becoming zero, and then positive. That's why rate of change is increasing. Rate of change is decreasing. So it's mean max point is start in the beginning is positive, then it goes zero, and then it becomes negative. So it's like this, and this is like this. So this is how we solve these kind of problems: finding derivative, finding turning points, and finding whether these points are min